Solution. Step I when the 18V source is acting alone, figure 3.83. From figure 3.83, Vx equals I. Applying KVL to the mesh. 18, I plus 2Vx. 6I equals 0. 18, I, 2I, 6I equals 0. I equals 2A. Step 2 when the 3S source is acting alone, figure 3.84. From figure 3.84, VIIXVV equals 1112 equals minus I. Meshes 1 and 2 will form a supermesh. Writing current equation for the supermesh. II21 I3 equals I12 2. Applying KVL to the outer path of the supermesh. Minus equals 1260 equals 26 minus 0. 12 minus 6. 122. IV2 plus 12 plus. I plus 21 plus 2I. X. 1 minus 360126 I6 equals 2I66. Solving x, 2, and 3. I. 1. 2. 2. 1. Equals minus. Equals. A. Equals II equals 2 1A. Step 3 by superposition theorem. I6 omega. Equals I plus I equals 2 plus 1 is equal to 3A. Solution. Step I when the 1S source is acting alone, figure 3.97. From figure 3.97, VI12 VIV200, I. For mesh 1, I11 equals 2. Applying KVL to mesh 2. 0200 0. 0200 40 40 200 0. 21200. 2241 2200. 541. 5. I 4140 I200 200 I1. I40 I2, II200 1 200. Minus 240 equals 2I200,000 200. Plus 2I4040 equals 2I200,000 200. 4140 0 12 140 II141 140 equals 2I140,000 140. 3. Solving x, 2, and 3. I. VII. V. 1. 2. 0 1 VI 2. 0 VV. 0 VV. 1. 0 29. 5200 0. 5229 0. Equals. Minus 1 2 equals. Minus 50. A. V. Step 2 when the 25V source is acting alone, figure 3.98. From figures 3.98, VI1 VV225 0 minus I equals VI1 VV225 plus I. Applying KVL to mesh 1. 05 40 225 0. 0200 25 40 225 0. 009. 1. 5. VI41 I40 I25 I. Minus I40 minus equals 25. 25 minus 200 I equals minus A. VVI01 VV 225 200 09 equals plus I200 equals 200.0 minus V25 725. Step 3 by superposition theorem. VV00 VV VV0 VV equals V0 VV plus V0 VV equals 108 plus 7 equals 115 V. Solution. Step I when the 5S source is acting alone, figure 3.80. From figure 3.80, IV equals 1 VV. 4. Applying KCL at node 1. Plus equals VIV11 plus VIV minus VV4. 145. VVV. 1VV11 plus VVVV4445. V1 equals 20V. Step 2 when the 20V source is acting alone, figure 3.81. Applying KVL to the mesh. For I 20 is equal to 0. I equals minus 20A. V1 equals 4I1, I equals 3I equals 3, minus 20, equals minus 60V. Step 3 by superposition theorem. V1 equals V1 plus V1 equals 20, 60 is equal to minus 40. Step I when the 100V source is acting alone, figure 3.74. From the figure, Vx equals 5I. Applying KVL to the mesh. 100, 10I plus 10Vx. 5I equals 0. 100, 10I plus 10, 5I equals 0. Equals minus I2. 86. Step 2 when the 10A source is acting alone, figure 3.75. From figure 3.75. VXVV, I1 2I minus I. Applying KVL to mesh 1. Minus equals 10 10 5 0 equals 10 10 minus 0. 1 minus 5. 1 1 0 5 2. IV plus 10 1 plus 10. I plus 10 1 plus 10 55 minus. X 1 2 minus. 555 minus 1 2 I 1 I. 35 45 0 1 2 45 I 45 1 45 equals 2 I 4545 2. For mesh 2. I 2 10 equals minus 3. Solving x 2 and 3. I 1 2 12 10 equals minus I 86. A equals minus II equals 112. 86. Step 3 by superposition theorem. II plus equals minus 286 1 minus 286 1 is equal to minus 5. 86 12. 72. Solution. Step I when the 17V source is acting alone, figure 3.77. From the figure, Vx equals a 2I. Applying KVL to the mesh 2I, 17, 3I to 5Vx equals 0 a 2I, 17, 3I to 5, 2I equals 0. I equals 3.4a. Step 2 when the 1A source is acting alone, figure 3.78. From figure 3.78, VIXVV21, I. Meshes 1 and 2 will form a supermesh. Writing current equation for the supermesh. II21 I1 equals I1 2, 2. Applying KVL to the outer path of the supermesh. Minus equals 2350 equals 2350. 123. 123. I33 minus V. I33 minus XV. 2 minus 1 I1. 830123 I33 equals 2 I33, 3. Solving x, 2, and 3. I. 1. 2. 2. 0 6. 16. 1. Equals I2. 6. A. Step 3 by superposition theorem. I equals I plus I equals 3.4 plus 1.6 is equal to 5a. Solution. Step I when the 5V source is acting alone, figure 3.71. From the figure, Vx equals 5, 10 I1. Applying KVL to the mesh. 5, 10 I1. 4Vx 2I1 equals 0. 5, 10I1. 4, 5, 10I1. 2I1 equals 0. 5, 10I1. 20 plus 40I1. 2I1 equals 0. I1 15. 28 0 equals 1 equals 0. 554. Step 2 when the two-way source is acting alone, figure 3.72. From Fig. 3.72. VIXVV 101 foot, I. Meshes 1 and 2 will form a supermesh. Writing current equation for the supermesh. I21I2 equals I12 foot, 2. Applying KVL to the outer path of the supermesh. Minus equals. 10 4 2 0. 10 2 minus 0. 1 2 2 minus. 1 2. I4 1 minus 4I. I4 1 minus 4I. X. 44 10101 minus 0 1010. 32 0122 I2121 3. Solving X, 2, and 3. I. 1. 2. 0. 214. Equals 0. Equals. 114. A. Step 3 by superposition theorem. I1 1,1,054,014 0 plus I12 equals 0 54 equals 0 I plus 54 0 54. 6,868. Step I when the 30A source is acting alone, figure 3.68. From figure 3.68. IIX1, I. Meshes 1 and 2 will form a supermesh. Writing current equation for the supermesh. II12 II30 equals I2 I2. Applying KVL to the outer path of the supermesh. Minus equals. 5140 equals. 54 minus 0. 1 2. 1 2 1. I11 minus. Minus I1. X. 9012 3. Solving X, 2, and 3, I. IIX. 1. 2. 1. 3. 27. 3. Equals. Equals minus. Equals I1. A. Step 2 when the 20V source is acting alone, figure 3.69. Applying KVL to the mesh. 2540. 2. Minus 5 minus 4. Equals 2. I1. I. XX1 I1X. X. 1 I1. A. Step 3 by superposition theorem. IIXXXII11X plus X3 plus 25 alpha.